All right, our last example has a lot of questions that are being asked on one set of information. So a strawberry farmer will receive $4 per bushel of strawberries during the first week of harvesting. Each week after that, the price will drop 10 cents per bushel. So drop, you should be thinking something negative. The farmer estimates that there are approximately 120 bushels of strawberries currently in the fields and that the crop is increasing, so we should think positive slope, at a rate of 4 bushels per week. When should the farmer harvest the strawberries? So we are looking for a time, T, to maximize their value. So we're trying to maximize some money happening. How many bushels of strawberries will yield the maximum value, and what is the maximum value in dollars and cents? So in this situation, we want to think about, we have two different quantities that are changing, right? We've got the quantity of strawberries, and then we've got the cost, right? So how much you can sell it for. Those of you that have taken economics, what we're really trying to do here is when we should harvest to maximize their value is we would like to maximize what we call the revenue. And revenue is going to be equal to the price times the quantity. So your revenue is how much you bring in. Let's say you're selling tubes of toothpaste. It's how many tubes of toothpaste, that's the quantity, times how much do you sell each one for, that's the price. Now, this is different than profit. It's different than cost, okay? This is just total amount of money that's being brought in. So that's what we would like to maximize. Revenue equals price, so money, times quantity, which will be the number of bushels of strawberries. So we need to figure out how to get our revenue equation. Instead of P's and Q's, we need to have that revenue equation be totally based on time, because that's what we're trying to look for is revenue. When should we harvest our strawberries? So I'm going to use two different equations to figure out how to relate to time, because my information that was given, a strawberry farmer will receive $4 per bushels of strawberries during the first week, and then we drop 10 cents per bushel for each week after that, which means that our price that we are able to sell our strawberries is based on time. The next thing then, I have approximately 120 bushels of strawberries in that first week, and then we increase at a rate of 4 bushels per week. So the quantity of strawberries is also dependent on time. Okay, so just thinking about basic independent-dependent relationships. Our price is based on time, our quantity is based on time, which means when I put those two things together, price and quantity, our revenue will also be based on time, which is what we were hoping for. So in week 1, we are selling at $4 is the price of a bushel of strawberries. In the second week, we lose 10 cents. So now we're selling at 3.9, which means that if I think about this in a continuing pattern, my slope is negative 10 cents, right? A drop in 10 cents a bushel, sorry. So if I write an equation for this, the price minus equals the slope T minus, right? Using our point slope equation. And I can use this point. In week 1, we were selling at $4, and our slope is negative 0.1. All right, so let's do the same thing with the quantity of strawberries. In week 1, we had 120 bushels of strawberries. In week 2, we now have 124 bushels of strawberries. In week 3, we have 128. So what we end up with here is a slope that's equal to a positive 4. So I can write an equation for this linear relationship that's based on time. That was my goal. So in week 1, we had 120 bushels of strawberries, and we have a slope that's equal to 4. So now I have price and I have quantity. I can isolate price to use in my equation up here, and I can isolate my quantity to use in my equation up here. So let's go ahead and do that. I'm going to end up with price equals, if you distribute this 0.1 in and add the 4 over, you end up with a price that's equal to negative 0.1 t. I don't like using t's, but we're using it for time, plus 4.1. Quantity then, I'm going to multiply this 4 in. Our quantity for the bushels of strawberries is going to equal 4t plus 116. So now I'm going to put those two things together. My revenue up here is going to be equal to the price that I'm selling the strawberries times the number of bushels of strawberries that I'm actually selling. Right? Price times quantity gets us revenue. So cleaning up this revenue equation, I'm just going to multiply together. I'm going to end up with negative 0.4 t squared plus 4.8 t plus 475.6. All right, so this is what I wanted to maximize based on time. So I now have my equation that gets the calculus based on a single independent variable of time. So R prime, running out of color choices, R prime is going to equal negative 0.8 t plus 4.8. I'm going to set that equal to 0 and consider where that may be undefined, but because it's just a linear equation, this will never be undefined, so I just need to worry about the critical numbers from being set equal to 0. I'm going to end up with t equals 6 weeks, because you subtract 4.8 and divide by 0.8. T equals 6 weeks. I need to then check to make sure that that actually is the maximum. So I'm going to use the second derivative. R double prime is equal to negative 0.8, which means that R double prime of my critical number, which was 6, comes back less than 0, right? Because it doesn't matter what you sub in there, you're going to get R double prime is negative. So we have a maximum going on. So when should we harvest our strawberries? Well, we will maximize our revenue. So we will have a max revenue at 6 weeks. So that's the when, right? That's the first question that was being asked. The next thing says, how many bushels of strawberries will yield the maximum value? Well, I'm going to go back to one of my helpers to find the number of strawberries. Q was the helper that helps with strawberries. So I'm going to take 6 and sub that into Q. Well, 6 minus 1 is 5, times 4 is 20, add 120. We're going to have a quantity of 140 bushels. What's my next question? What is that maximum value in dollars and cents? So if I'm selling 120 bushels in week 6, if I plug 6 into the other helper, my price per bushel is going to end up being $3.50. So I'm selling 140 bushels at $3.50. My actual revenue is going to be equal to $490 if you multiply 140 times 350. $490 is what I'm going to be bringing in. So what you want to think about there, we'll do another problem like this that deals with peach trees, okay? And what you want to think about is that as the season moves along, right, the price that you can sell them for gets cheaper, but you have more of them. And so you're trying to find that perfect break in your threshold to figure out what is the maximum revenue that you can bring in. What would be the best time to be selling your strawberries? Because you're going to have a lot of strawberries and the price that is being demanded is also creating a maximum. All right, so we'll look at this again from an economic standpoint. Those of you that have taken econ, revenue is super important. There's a lot of optimization that goes on in your economics classes, and we can talk about that when we come together on Wednesday for our review day.